Hello, my name is Emir Leslie, and I'm a doctoral student with California Intercontinental University. Today we'll have a discussion on conducting a chi-square test of independence. This is our agenda. We're going to talk about the terms and definitions. We're going to go over Kramer's V's interpretations. Next, we're going to look at the chi-square data set, followed by the discussion of the three different data set results and the one significant result. We're going to talk about some takeaways after that, and then we're going to conclude it, and we're going to ask for questions. So as we look at the terms, we see that chi-square test of independence is a non-parametric test that establishes the independence of otherwise between two nominal variables. The contingency tables is a table showing the distribution of one variable in rows and another in columns, used to study the association between two variables. Kramer's V is a way of calculating correlations in tables, which has more than 2 by 2 rows and columns. It is used as a post-test to determine strengths of association after chi-square has determined its significance. The dependent variable is the variable of primary interest to the study, and it's also known as the criterion variable. And the last term that we have is the independent variable, which is a variable that influences the dependent or criterion variable and accounts for or explains its variance. Next, we have Kramer's V's interpretation. So as we look at this, it shows the strength of the association starting with the 0.00 p-value, which shows no relationship, and then it says that there's no relationship to consider, and it goes all the way to the p-value of 1.00, which is perfectly symmetric, and this is very rare. The independent variable perfectly predicts the dependent variable. Next, we have the chi-square test sets that we're going to look at. So we're going to look at numbers of cars versus the number of defaults. We're going to have the Likert comfort scale, looking at versus the number of defaults, and finally the number of cars versus the Likert square or the Likert scale comfort. So as we look at the first hypothesis testing, it says the following chi-square test was conducted. So the null hypothesis states that there is no relationship between the number of cars and the number of defaults, while the alternative hypothesis states that there is a relationship between number of cars and number of defaults. Now the chi-square statistics and its p-value was calculated using the PSPP, assuming that the value was 0.05. So we found out that with the test that there's no relationship that emerged. We see that basically the chi-square was 6, the number is 150. We've got 6.68, p-value 0.351, and the Kramer's V is 0.15, which is basically no significance. The second hypothesis test that we have is we have the null hypothesis stating that there is no relationship between the Likert comfort scale and the number of defaults, while we have the alternative hypothesis stating that there is a relationship between the Likert scale comfort and the number of defaults. So again, we look at the chi-square statistic and its p-value being calculated using the PSPP, assuming that the value is 0.05, and we see that there is a relationship that emerged. There is no significant relationship that emerged with the value being 0.15. And the last test that we have, we see that the null hypothesis states that there is no relationship between the number of cars and the Likert comfort scale, while the alternative hypothesis states that there is a relationship between the number of cars and the Likert comfort scale. Lastly, we're using the chi-square statistic p-values being calculated using the PSPP. And we see that there is a relationship that emerged because of the Kramer V being 1.00, and as we stated, that's showing perfect asymmetry. So it says that there is is 100% chance that that there is symmetric with the relationship. So the takeaways that we have is the first one is the PSPP model can perform the chi-square test of independence. So this is the first and foremost takeaway because it validates the testing mechanism. Next, the process of performing the test is through using the analyze, the descriptive statistics, and cross tabs within the module for PSPP. The third takeaway, which is the most important of all the takeaways, that it is important to obtain Kramer's V, because Kramer's V will determine whether the relationship is asymmetric, and the beginning from 0.00 all the way to being 1.00 with it being symmetric. Perfect asymmetry, as the table states. And the last takeaway that we have is that even though we see that the third hypothesis test was significant, we need to make sure that we include both a significant and insignificant chi-square tests for comparison. So we're comparing the different testing chi-squares in order to determine the action that's needed to build on our null hypothesis and alternative hypothesis. So this concludes our discussion on the chi-squared testing for independence. So if there are any questions, I'll take them now in regards to the definitions, clarification on the definitions, a little more in-depth discussion on Kramer's V's interpretations. If there was any questions on the chi-squared data sets that were used, any questions involved with the discussion of the three results, with the one being significant, and if there are any questions on the takeaways, please post any questions that you have so I can get back to you with an answer. Okay, thank you for taking your time out to be part of this discussion. Goodbye.